Graded 3 students, we got another lesson today, continuing with our journey of understanding circles better. We're going to find some cool new relationships between different parts of circles and different things that we draw in them. So let's go ahead and get into it. Alrighty, let's go ahead and in our notes draw a line, and let's go ahead and write chords and secants. That's what we want to do, chords and secants. And the first sort of subheading, we'll put a little star. Let me actually change the color of this. Let's make it black. That's fine. All right, first little star subheading is chords. Let's say lengths of intersecting chords. All right, so the first thing you have to know, of course, is what is a chord? What is a chord? You should have written down that definition. Those definitions were due Tuesday, which today is Friday. So this should be long done, and you should have a definition for a chord, okay? Well, let's go ahead and please open up GeoGebra. Remember how to get there. You can type in, well, you want to spell it right, of course. Geometry. Do I even know how to spell it? Probably not. There it is. Okay. GeoGebra geometry. You can type that into Google. I think I sent a link last time, but just GeoGebra geometry. That's what we want. Got it here. Let's go ahead and create ourselves a circle. Okay. Boom. I've created a circle. And now let's create chords. A chord is a segment. We'll start this at B and we'll go to another point C here. It's a segment that intersects the circle on its, or intersects the circumference. Both points are on the circumference. So this would not be a chord, just a line segment inside of it. Both of the endpoints are on the circumference. So it's a segment with both endpoints on the circumference of a circle. The chord that goes through the center point is called a diameter. I don't know if that's a part of your definition, but it'd be a good idea to either write that down or remember it. A chord that goes through the center is what we know as the diameter, okay? So once you draw your chord, of course, we can move it around. That's what's so fun about GeoGebra. And again, if you need to rewatch any of this, rewind, see the steps. That's what makes these videos nice, is you're able to control the speed here, okay? I don't know how many people watch me in 2x, but I think that would be too fast for what we're doing, okay? All right, so we have one chord. Now the topic is not single chord, it's intersecting chords. So we need a second one. So let's make this chord D to E. There we go, D to E. All right, these are intersecting now, and we want to actually label this intersection point. We're gonna grab our point tool on the left side here, and we're just gonna click the dead center, okay? And it makes the point F. So we have our intersecting points, and what I'd like you to do is I want you to draw a simple diagram. Obviously I can just copy and paste here, but draw a simple diagram of this in your notes, okay? Please go ahead and do that. All right. Now we'll come back to this in our notes, but let's measure some lengths of this chord, okay? So let's go ahead and measure. You grab this, you're going to do show more, and we need our measurement tool for distance or length. So we're going to click that. Now it says select 2 points, a segment or a polygon or a circle. We want to do 2 points at a time here, okay? 2 points. So we're going to go from D to F, from F to C, from B to F, and E to F. Okay, now you'll notice something about these shapes. I'm actually going to move this here. Okay, that makes it better, because I didn't want you to say, oh, well, this is 5 and that one was also 5. That was a coincidence. Let's just go like right here, okay? And we have these lengths, all right? And we're going to go back in our notes and we're going to do this. We're going to label these as A. So in your notes, you're going to write this on in your notebook, B, C, and D. Okay? That's how we're going to label those. A, B, C, D, the segments. Okay? And there's a rule for this. I want you to do this with me. If we call this A, B, C, D, the rule is that A times B should equal C times D. All right? So I'm going to show that. Hopefully I can show that with a calculator. It's going to be close. These are rounded, by the way, these lengths. So it might be slightly off. But in general, this rule is going to be true for these chords. 4.2 times 3.9. So that's 16.38. So let me actually write that in here. We're going to say DF times EF. Yeah, EF equals, we got 16.38. I think there's a way that I could actually, you know what, let me try to figure out how to auto show that. I think I can do it. Hold on. All right, through some special coding, I was able to do it. So this value here is going to be both of these multiplied, and this value here is both of these multiplied. So the values are going to change, and you'll notice that they are always going to be equal, okay? If I look at some of the settings here, like I can even change, well, maybe I can't. I thought I could change the number of decimals. It doesn't really matter. We're seeing the point here that multiplying these make them equal to each other. So we're going to add in our notes here that A times B equals C times D. Now we could also write this like this, which is what I want to do, but you're not going to use this formula. You'd rather use the multiplication. It's a little bit simpler. But we could rewrite this as A divided by D equals, actually no, hold on. A divided by C equals D divided by B. Okay? Now look at our diagram and let's think about that. A divided by C is equal to B divided by D. I connect lines here, right here. We get two triangles, and these triangles are similar. So just the same way that we talked about how Eratosthenes found the circumference of the earth using similarities with circles, in these circles we create a lot of similar figures. In this case, similar triangles being produced. Let's go back to GeoGebra, and we can do that. We can draw this. If you want to draw with me, connect these points. We get we're going to measure the angles. We know that these angles have to be congruent, which, by the way, I'm going to get rid of these measurements now, since we know that that's always true. So we have this. I'm going to measure this angle. We know these are congruent because they're vertical angles. We talked about that with the giant circle problem. Measure the rest of these. Yeah, and I'm clicking 3 points, by the way, to get these angles: D, C, F, and here. And you'll notice if we move these values around just so we can see them clearly, we have two similar triangles, okay? Because all the corresponding angles are congruent, and you remember that from last year, and they're always going to be congruent, the corresponding angles, okay? All going to be congruent. So it makes two similar figures, which is why these rules work, okay? So it's pretty neat. Apply this to Delta Math. Okay, let's go to Delta Math and let's begin by talking about some of the problems on here that you can work now. We look at, we'll go to circles, and we're going to go to this right here, intersections of chords. Okay, so here we have the problem where we have these lengths. If we label this A, B, we call this C and D, we can multiply them. We're going to do 2 times X equals 8 times 11. That gets us 2x equals 88, which gives us x equals 44. So my answer should be 44. So we go back to Delta Math, type in 44. No problem, right? We got it. And so these can be made more complicated, obviously, with more variables. Like I could make this x plus 1 or multiple binomials in here, and we could do some more advanced algebra, but that's not really the point of this. The point is the geometry concept of how these are related to one another. They create similar triangles. That's why this works. It's just like last year in iMath 2 when you learned about similar triangles and how they are proportional. That's why this is working, okay? So that's the true concept here. Do I need to throw difficult algebra at you? I don't really think so. Might I do it? Yes, okay? But I expect you to know the algebra at this point if I throw some of that on you, okay? All right, let's start over. Let's do the next idea, okay? So I'm gonna go back here. We've got that written down. Now, actually, let's make you're gonna draw, no, you won't draw a new figure. You're gonna write this next one, this next part. Yeah. This, go back to black. We're gonna say angles of intersecting and secants. So what is a secant? Well, a secant is almost identical to a chord in that, let's go ahead and start a new diagram here. I'm just going to show this and we'll do some examples, but we're going to be using chords for this. But a secant is the same thing as a chord, except you use a line instead. So here I have created a secant, and whatever happens to this, the secant will go through the circle, but it's going to extend to infinity. But the properties work the same way as if I had two chords intersecting. So I could do another one right here, and the lengths, the way that inside of the circle work the same way. It makes proportional triangles. But we're not interested in that. Well, we kind of are, but we're going to do something different with this, okay? So we need to make two more chords. So go ahead and do that. Let's make B, C, and A, or D, E, okay? All right, we've got that. Now, I want to find, got it created. Let's draw this circle, put that in our notes, make another circle diagram. There it is. And again, yours can be simple. All right. I want to know, first off, what are these? I want to know what is the measure of these arcs, right? So arc measures. That's what we want to know. What is the measure of the arcs CE and BD? Well, we have to think about how to find this. And I asked this question in person yesterday, and it took them a minute to think about how we can find it. But we have the tools to do this. Okay, we do have the tools to do it. It's a little bit more awkward to sit and have wait time. I do want you guys to think about this. How can we find the arc measures that I have identified? Okay. I think I'm going to go ahead and just talk through it. We know that the arc measure, we have a rule, the arc EC, this measure will be equal to the measure of the central angle, okay? And what we can do, if we use the move tool, we can actually change the color. So let's make these red, and these are going to be our central angles. And if you want to make them dashed, we can. That won't be too bad. But we don't want to, like, that's what's confusing sometimes with GeoGebra is we have all of these lines, and sometimes we get lost, right? So there is no measurement tool for arc length or arc degree, because we have this way of finding it by saying, oh, it's congruent to this. So let's measure arc, or this angle CAE, okay? And what we get is 41.9 degrees. So this, I'm gonna make that red as well. So I know that on my measurement here, we can put 40. Let me undo here. I can change this to, maybe I can't. Okay, 41.9 degrees. So we'll start there, 41.9 degrees. Okay, now we're gonna look at the other one over here. We're gonna do the same thing. I'm gonna create two segments going to this arc right here. Let's color those, oops. Let's color those red, and we'll make them dashed, red, dashed, and red. And we're gonna make the angle measure between them, D, A, B. There we go. And we're gonna make that red. I know I'm flying here. If you need to rewind, if you wanna try to create this on your own, you can, or if you just kinda wanna sit back and watch, spectate, it's fine with me. There's quite a bit going on here, okay? And at this point, this diagram looks pretty crazy, okay? A lot happening. Kinda hard to follow, but I've kind of ruined it by changing these. So let me actually I'm gonna change 39.7 and 40.3. 39.7 and 40.3. Okay, there we go. All right, we've got those arc measures. Now, I want to know what is this measure here and also here. Okay, let's find those. So that's pretty simple to do. We know that we can add a point here and we can calculate the angle. So we're gonna do that, boom. And these should be congruent because what type of angles are they? Well, they're vertical angles. So we have vertical angles here, and we kind of saw that in the giant circle problem yesterday, where we had to find a couple angles using these vertical angles, okay? So we got 40. All right, so let's, let me write that in. So 40. Okay. Now, we want to find a relationship between these values. So let's see if we can find something. We notice that these equal 40, but how can we relate, we see that these equal 40, how can we relate these two to the ones here? Now I want you to see this. When I make all of them the same, let me make whole numbers. That's what's problematic with this. When I make them all the same, or when I make the arc measures the same, you'll notice that everything is congruent. Look at that. All of these are going to be congruent. So this arc is 39 degrees. That means this one is, but this one also has to be. As soon as I change that, I'll make this 55. 55, and we'll make this one, let's make this one 35. Right there. We see that, you know, they're not all the same, but there is a relationship here happening between the red angles, even if they're different, and then what's happening here, okay? Let me do a few more examples and see if you're able to notice it. Let's go to 45. This is so difficult to do. In class, I'll sit there forever just trying to do it. Okay, so 45, when we compare these, it's 50. Make a really exaggerated angle here. Let's go 75. 75, 55, 60. Let's do some whole number angles. Let's go 70 and 50. That gets me 60. Okay, and you might be noticing that these values that we're getting in here are sort of halfway in between the points. So let's go 60 and 50. So we expect 55 with this, right? So there is a relationship between these. It's sort of halfway in between them. It's the middle of them. Or a better rule, if we're adding the two red angles, we can divide them by 2 to get the next one. Okay? We add the degree, the arc measures, add these together, 39.7 plus 40.3, divide that by 2, we get 40. There's the rule right there. And actually, we are going to write down this official rule. Where did it go? Add it up. Is it gone? 1 second. Let me get the rule up. Yes, here it is. Okay. So here we have, if two secants or chords intersect inside a circle, and we're not talking about at the center of the circle. This is not central angles here. Central angles would be a lot easier. We would know how to find all those. But if they're just intersecting, then the measure of the angle formed is equal to half the sum of the measures of the intersected arcs. I'm going to pause and make sure that you write this down next to that, okay? So basically, well, let's go ahead and pause. Basically, we always, to find these angles here, because this one wants measure of angle AED, so we want, here, we're going to do both of these here. Actually, I think these are in your practice problems. I can't remember. We'll do the top ones here, AED and STR. So we'll do both of those. I want to fit them both in the screen. There we go, okay. All right, so we want to find this angle here. Okay, what is that? Well, all I have to do is add 45 plus 109 equals our mystery angle. Oh, excuse me. And then we have to, so I'll put that in parentheses because we need to divide by 2 on that one. We're going to divide by 2. So let's do that. 45 plus 109 divided by 2. So we know that that is equal to 77. So that's our answer for this. We go over here. So secants work the same way. We have the same properties. It just secants go on forever. So we want to find angle STR. STR. So STR, we're trying to find this angle here. STR. Well, we add them and divide by 2 to get that angle. So it's 186 plus 112 divided by 2. It's 149. That's what that one's going to be. So let's look at delta math. I've put up some examples. So this is lengths, but I have some examples here. Properties of chords. We're not ready for that one yet. Intersecting chords and secants. I guess we're going to do this one last for our lesson today. But intersecting chords and secants, this is the section that we're working on right now. Here we have the question. This one is the one that was, actually, I want to do a different one. Let's do this one here. This one's better, okay? Find the measure of L. Okay, we're trying to find the arc measure. We have 62 and we have this. So we don't really know what we don't know what this is, so we're going to put an X here, right? That's our mystery. That's what we want. But we know that if we take 74 and X, if we add those, so 74 plus X, and divide it in half, it should equal this middle angle, 64. So we can do some algebra here. Multiply by 2. We get 74 plus X equals, I think that's 128. And then we subtract 74. I'm just going to grab a calculator for that. 54. Okay, so that would be your answer to that question. All right, that is going to be your answer to that question. Cool. All right, last properties of chords that we're going to talk about. And then we'll be done with our lesson. So final topic for chords. So we have chords and intersecting radii diameters. All right, let's write that in our notes. And we actually want to add to this, want to add to this description here, chords and intersecting radii diameters. Let's actually change intersecting to perpendicular bisecting radii diameters. Okay, that's what we want. All right. Okay, so go back to GeoGebra. We're done with our intersecting secants and chords, and let's create a new slide, a new diagram. Let's go ahead and draw us a circle here, that here, and then go ahead and draw yourself a chord. Okay, draw a chord. Now, what I'd like you to do is I would like you to draw a, we're going to go down to the construct section, and we want to construct the midpoint of this chord. So we're going to click midpoint, and then we're just going to click the chord itself, and it's going to create that midpoint E for us. Okay. Now the next thing we're going to do is we're going to draw a ray through there. Okay. And that seems fine. We know that to this point, like from A to F here that I've just created, that's the radius, right? So we want to talk about the relationship between these. Okay, if I start moving this around, or either of them start moving, change the size of the circle, what is the relationship between these parts? Well, first off, if you have a radius that intersects through the midpoint, so a midpoint is just the center of the line, right? Let's create an angle AEC, okay? AEC. You'll notice that it's always going to, so part one is any radius that intersects through the midpoint of a chord will always be a perpendicular bisector. That radius will be. And so when we bisect it, this is what happens. We're going to measure the distance E to C and E to D, and look at those lengths. They are congruent. Okay. There we go. When a radius or diameter goes through a chord, through its center, it's going to create a 90-degree angle, and these are congruent. Also, if we know that a radius is perpendicular, it works the other way. We know that it's at the midpoint, okay? So that's always going to be true. We need to write down this rule right here. Oh snap, hold on. We want to write down this rule. I'm going to actually copy and paste that for you guys. We just want this. That's all we want. So I'm going to write that. I'm going to paste that right here for you guys to write down. So if a diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So not only is it bisecting the chord, well, I'm going to pause and let you guys write that. All right. So not only is it intersecting the chord, it's also it's bisecting the chord into two congruent parts, but it's also bisecting this arc, half and half. Okay. It's also splitting that measure in half. Okay. So let's look at some questions that you're going to have for this. So that's this section here, properties of chords. So if we look at this first problem here, all right, here we have a question. And this one, a lot of these questions, you don't even need the rule. We can just figure out what it is. So X is going to be, X is a radius. And then over here we have a chord that's being intersected perpendicularly, which means this is bisected. So we know that this is 11.8 for this line down here, but we know that the radius is going to be 6.3 plus 7.1. So the answer for this one should be the sum of 7.1 and 6.3, okay, which is going to be 13.4. So that should be your answer on that one. Let me find a better another example where I think it's 2. No, not that one. Maybe it's 4. 4 is good. Okay, so on this one, find the length of the segment indicated. All right, so we see that this radius is intersecting perpendicularly. It means it bisects. So what should x be? Well, they should be congruent because this is going to split it evenly. So our answer should be 2 on this one. Okay. Now there's some other problems on here that are a little more challenging. For instance, on this question, in order to find it, this is actually a pretty good problem. I'll work this one. In order to find x, we know that the total distance from here to here, that should be 17. Well, why is that? Because it is the radius. So 17 is the radius here. That means the whole thing has to be the radius 17. So what we need this part here to be able to help to find it. Well, that means we need this small part. Well, since it's a right triangle, that means we're going to use Pythagorean theorem. All right, so this would be 14.1 squared plus b squared, which is what we don't know, this question mark, equals 17 squared. So I'm going to subtract 14.1 squared, so we get b squared equals 17 squared minus 14.1 squared. And then I'm going to have to square root all of that. So this is sort of like our distance formula, but there it is. So let me grab my calculator for this. And let's do square root 12 squared minus 14.1. We're going to square that. Hit enter. What did I mess up? Oh, I did 12. Why did I do that? Hold on. Yeah, okay. Let me fix that. So back up. 17. Okay, 9.496. That's going to be this length here. 9.496. I believe I have that right. Yep. I guess I could do 7. So it's going to round to the nearest 10th on our final answer. So how do I get x? Well, I need to take 17 and subtract this. So I want 17 minus this. So 7.5 would be my answer. So that's 7.5. Let's try that. We got it. Okay, cool. So that's going to conclude the lesson that I wanted to get out today. You should be able to answer really all of this first part. The next lesson that we do will be talking about tangent lines, and that's pretty much going to wrap things up for us here, and we'll just be doing a lot more practice in the following week. So I'm going to go ahead and stop the video here.